Good morning, students. Today we will diagonalize the matrix A is equal to 10, 3, 4, 6. To diagonalize the matrix, first we have to find out its eigenvalues. The first step is to find the eigenvalues. For that, A minus lambda I into x equals 0. That is 10 minus lambda 3, 4, 6 minus lambda into x is equal to 0. Then determinant A minus lambda I is equal to 0. Determinant A minus lambda I equal to 0. Then result lambda square minus trace of A into lambda plus determinant A is equal to 0. Then trace of A, lambda square minus trace of A, 16 lambda, sum of diagonal elements, plus determinant A, 48 equal to 0. Therefore, lambda square minus 16 lambda plus 48 equals 0. Solving this equation, the value of lambda is equal to 4. Therefore, eigenvalues are 4. The eigenvalues are 4. And based on these eigenvalues, we have to find out the eigenvectors. Next, we have to find out the eigenvectors. Lambda equal to 4. Lambda is equal to 4. The eigenvectors is equal to 10 minus 4. 10 minus 4, that is equal to 6, 3, 4, 6 minus 4, 2. x1, x2, 0, 0. Then 6, 3. 6, 3 can be taken as dividing by 3, 2, 1. Then 4, 2 can be taken as 2, 1. That is equivalent to 2, 1, 0, 0. Therefore, our equation will be 2x1 plus x2 is equal to 0. Hence, rank is 1. Therefore, rank is 1. Number of unknowns 2. Therefore, 2 minus 1, 1 variable, put it as arbitrary. x2 is equal to t. Therefore, 2x1 is equal to minus t. x1 is equal to minus 1 by 2t. Therefore, the eigenvectors are minus 1 by 2, 1. That is minus 1. Therefore, lambda is equal to 4. Lambda equal to 4. The eigenvectors are minus 1, minus 1. The first eigenvector is minus 1. Next, we have to find out next eigenvector. Lambda equal to lambda is equal to 12. Therefore, 10 minus 4, 10 minus 12, the 10 minus 12, that is equal to minus 2, 3, 4, then 6 minus 12, minus 6, x1, x2, then 0, 0. Then minus 2, 3, 2 minus 3. Matrix that is equivalent to minus 2, 3, then 0, 0. 0, 0. Therefore, our equations will be minus 2x1 plus 3x2 is equal to 0. Since rank is 1, number of unknowns 2, therefore 2 minus 1, 1. Therefore, we choose one variable as arbitrary. x2 is equal to t. Therefore, minus x1 is equal to minus 3t. Therefore, x1 is equal to 3 by 2t. Therefore, the eigenvector is 3 by 2, 1. That is 3, 2. Therefore, lambda equal to 12. The eigenvector is 3, 2. Eigenvector is 3, 2. Therefore, we get the two eigenvectors are and the first eigenvector is -1, 2, and second eigenvector is 3, 2. First, we find out the eigenvalues. Based on the eigenvalues, we find out the eigenvectors. Then write the model matrix. Then write the model matrix. Model matrix equal to X is equal to, write these eigenvectors as column. First eigenvector -1, 2. The second eigenvector 3, 2. When we write this, this is known as model matrix. Model matrix is represented as X. X is equal to -1, 2, 3, 2. -1, 2 is the first eigenvector, 3, 2 is the second eigenvector. Model matrix. Then D, to find the value of D, diagonalization, D is equal to X inverse X. We use the formula D is equal to X inverse X, X inverse X. Then we can find the X inverse. X inverse is equal to, we can use the formula 1 by determinant A into adjoint A. 1 by determinant A into adjoint A. Here 1 by determinant X into adjoint X. Then X inverse is equal to -1 by 4. -1 by 4, 3 by h, -1 by 4, 3 by h, 1 by 4, 1 by h. X inverse. We can calculate the X inverse by using the result 1 by determinant X into adjoint X. Then X inverse is equal to -1 by 4, 3 by h, 1 by 4, 1 by h. Then X inverse A, X inverse about -1 by 4, 3 by h, 1 by 4, 1 by h into, given matrix is 10, 3, 4, 6. Then X is equal to -1, 3, 2, 2. Therefore, this is X inverse. X inverse calculated by determinant X into adjoint X, -1 by 4, 3 by h, 1 by 4, 1 by h. Then A is equal to 10, 3, 4, 6. Then X -1, 3, 2, 2. -1, 3, -1, 3, 2, 2. Then by multiplying this matrix, you will get the result as 4, 0, 0, 4, 0, 0, 2. This is the diagonalization. Our required diagonalization will be 4, 0, 0, 2. This is the diagonalization. But to find out the diagonalization of a matrix, the first step is to find the eigenvalues. First step is to find the eigenvalues. Next, we have to find out the eigenvectors. Then write these eigenvectors as column. Then we make a new matrix. That new matrix is known as model matrix. X. Then after finding X, find out the X inverse. X inverse, we know the formula 1 by determinant X into adjoint X. By using the result 1 by determinant X into adjoint X, we can calculate X inverse. X inverse is equal to -1 by 4, 3 by h, 1 by 4, 1 by h. Then to calculate D, diagonalization of the given matrix, we use the formula X inverse X. Here X inverse is equal to -1 by 4, 3 by h, 1 by 4, 1 by h. The A is equal to 10, 3, 4, 6. 10, 3, 4, 6. X is equal to -1, 3, 2, 2. Then multiplying this, we get the result as 4, 0, 0, 2. Here we take first eigenvector is -1, 2 as the first column in the X. Therefore, first 4 will appear as first. Then second eigenvector taken as second column. Therefore, second value lambda will be appear here. Therefore, 4, 2. Therefore, all other elements will be zeros. This is the required diagonalization of the given matrix. Okay.